Okay, so for this problem, we're going to use the right-hand sum to find the estimate of the area underneath the curve. So it's basically this area in red that I'm going to draw. It's this, all the way to 20. We're going to find that area. We're going to know what's the area. So in order to find the area, we're going to use this thing called the right-hand sum. And we're going to use n equals to 6. So what that means, n equals to 6, it means that we're going to divide from this section, from -1 to 20, we're going to divide it into 6 evenly parts. So let's see if I can do it here. So it's going to be 1, 2, 3, 4, 5, and 6, right? There's 6 portions. There's this first part right here, right? That's 1. Let's see if I can do just an X. Stop. X. So this area that's in yellow. All right, we're finding that area. So there's 6 parts. Okay, so we're gonna find that. And what the right-hand sum is, it means that the right point, that the right corner, we're gonna basically form 6 rectangles, and the right-hand side of the rectangle, it's gonna touch the line that we're looking for. So just like this. That's our first one, and as you can see, this one's a little bit too high up. So the next one is going to be this from here. So notice how the right hand side of the rectangle is touching everything. Okay, and the last one, 3, 5. Yep, we have 5 boxes. Now this one, there you go. See, so now we have 6 different rectangles. Okay, so now the question is, what is my delta x? My delta x. So delta x is the width of each one, right? The width of each rectangle. So we said that we're gonna divide it into 6 evenly pieces. So keep in mind that the sum, the length from, let me do it in black, from here to here is 21 pieces, right? It's 21 numbers, right? So if you were to count 1, 2, 3, 4, 5, 6, all the way to 20, it'll be 21, right? So keep that in mind. So it's 21 divided by 6. Each one of this measures 21 divided by 6. All right. Each box has a width of 21 divided by 6. Let's do this in black better. Okay. So now we have that. All right. So now if we want to find the area of each, right? Because remember, we're trying to add the area of every of these rectangles individually. Let's look at the first one. On the very first triangle, let me use a different color. Let's use blue. What is my y? What is this point right here? Right? In order to figure this out, you have to keep in mind that we have this function. Let's say it doesn't have a function name, so let's just say g of x, and we already know that that is 2 over x plus 1. We already know that. So in order to find my y, this part in blue, we have to, guess what, plug in negative, not -1, but the one to the right side of -1, which is going to be this part right here, right? Where does that touch? Okay, so in order to find the y value, right, we have to plug in the x value to this function to give us the y. So that's what I'm doing here for every single one of these. Okay. These are the corresponding x values. So 2.5 would be this one, this first one, 2.5, and then this would be 6, then this would be 9.5, then this will be 13, this will be 16.5, and this will be 20. Okay. Keep in mind that my graph is not to scale. That's the reason why you'd be like, how is 2.5 right here, right? But my graph is not to scale. All right, so keep that in mind. And these are all the right points, the right hand side of the points, which is that's all these. Sorry, it's really hard to draw. These are all these blue points. Okay. So then now we would plug this into the formula, the equation, and we know what delta x is. Delta x, we said that is 21. This one right here, it's 21 over 6 times whatever G20 is, right? G20, it's going to be 2 over 21, right? Which is, I plug in the 20 here. All right. So, and then the next one, it's going to be 2 over 17.5. 0.5 plus, etc. Right? All right. So when we do that, we get an approximation of, let's see, we get an approximation of 4.9. Okay. So hopefully this all made sense. Okay.